How many people here are gamers, in particular massively multiplayer online role-playing games, MMOs? Raise your hand higher, it's okay. Whatever we say here won't go anywhere any further. I know we're all a little embarrassed about that. And what do you think is the average age now for a gamer? About 36, 35, somewhere in there. So what that means is people are continuing to do it and even pretending that they're not, because somehow it's thought of as an adolescent thing that we should give up as we get older. And I believe that what's going to happen is quite the opposite. I believe that games have an amazing ability to, number one, create engagement, and number two, to drive collaborative behavior without being ordered to be good and cooperate. There's something about the game dynamic that does that, and so I'm quite taken with this, talking about it. What I'll present here is a single example of using game technology to visualize big data. Back in the day, just maybe only 10 years ago, what was the big driver of technology on the internet? We all know. Yeah, pornography, right? Right. What is the big driver of technology now? What is the most popular activity other than just keyword searching on a search engine? Gaming. It's gaming. And so the technology of gaming is quite, I think, quite amazing. And so bear with me, humor me if you think I'm crazy. Right now, these are the kind of data visualizations that we do. These kind of visualizations are about 200 years old, give or take, maybe 300 years old, and they are two-dimensional, X and Y. Now that's the problem, is here we are suddenly flooded with big data, and we're trying to make sense of them in Flatland. Does anyone know of that book called Flatland, or read the book called Flatland? Written, pardon? Well, actually a Brit from 1884 wrote this book. And he wrote it, he was a mathematician himself, and he wrote it somewhat as a parody of social norms at the time, Victorian norms. It's still quite relevant. We are still stuck in Flatland. And this is a sketch that he did from his book. Now, in the book, there is a character named A Square, and A Square is a renowned mathematician in Flatland, and A Square is visited one day by a sphere. A Square, living in Flatland, has no way of comprehending the totality of a sphere, so the best that A Square can figure out is that a sphere is a series of circles, right? And it's true, but does that really give you the sense of what a sphere is, a circle? No. It's an infinite number of circles that combine to create something that is entirely different than a circle. So after a dialogue between a sphere and a square, finally, sphere says to square, you have to come with me to a place that you do not know. And take it on faith, and I will show you some things that you have never imagined. So what we'll do here is I'll first talk in a somewhat of flight of fancy. I'll show some pictures that illustrate this notion of fantasy, and everyone will go, yeah, that's great, Mike, except how will we ever get there? And then I will come back to Flatland and talk about literally a project that I'm doing right now to get into this three-dimensional world. So science fiction people, I'm a big reader of science fiction, especially the kind of science fiction that tries to postulate, tries to put together new technologies and talk about their social consequences. So there is an author who I'm somewhat partial to, William Gibson. Anyone read any of William Gibson's work? And I quote him here, and I'm going to go ahead and read him because I love his language. Cyberspace, a consensual hallucination experienced daily by billions, a graphic representation of data abstracted from the banks of every computer in the human system, unthinkable complexity, lines of light ranged in the non-space of the mind, clusters and constellations of data, like city lights receding. He said that in 1984. So here we are in cyberspace. We use the term all the time. It is a reality. Another science fiction writer, he wrote a book called Snow Crash. He is credited with coining the term avatar. Actually, avatar comes from the Hindu religion, and it's a very ancient term, but he brought it into more current usage, and he talks about that whole notion of you being in cyberspace. He calls it the metaverse, as an avatar. And in the game world, we're beginning to realize that 3 dimensions are very powerful because we are humans who live in a 3-dimensional world, and having an avatar, especially one we customize, we start to identify with. We have these mirror neurons in our head, and they start to lock on to the avatar almost as if it was really us. And he also points out something, which is that in the metaverse, it's always nighttime, because the black spaces are the spaces where data can be filled in, and then all the bright light spaces, that's where the data is. So this is actually a picture of Times Square from the Strata conference last September, but it looked like the metaverse to me, and I saw some avatars there. And then imagine that you can, in this 3-dimensional non-space of the mind known as cyberspace, your avatar can go into separate data spaces. And environments like Second Life are starting to hint at what that might be, although I think we're still very early in this evolution. And something like, not only are we talking about 3 dimensions, but let's also add in sound. You know, if we start to ascribe sound to the data, then it's becoming even richer. So now we are in a space where we can navigate. And guess what? The user interface to navigate in 3-dimensional space isn't that hard. As a matter of fact, elegant simplicity is going to get us there much faster than devilish complexity. And it's because we're born. We are 3-dimensional creatures. So imagine that we could fly around in this 3-dimensional space, scanning for visual patterns that attracted our interest. And then you zoom in on something, and then you start to use shapes and colors and sounds as a way of showing the data. And big data is one thing when we're analyzing historical caches of big data. And yet I think the real challenge now is to live in a big data, real-time world. So navigating through big data in real time is the challenge. It's act now instead of later on do a post-mortem of what we could have done. So I'm imagining in this case here that imagine that circle is the size of your market share at that moment in that space, and you are seeing usage vectors from the people right there using your product. And as you're flying through that 3-dimensional space, you could then go and talk to avatars about what do they think about your product. Okay, so it's really cool, Mike. But that's kind of neither here nor there, buddy. So here we are. We're back in Flatland. And I have certainly seen some very sophisticated 2-dimensional renderings of big data, and they do start to hint at patterns. We can see those patterns, but they lack a certain richness. And they often require, I have for instance seen talk about people who live in a real-time 3D world that is streaming data. It's a stock, a day trader, a stock trader. And they have these heat maps, and they move around, and they're completely incomprehensible, such that they even show them to people, knowing that unless you have had detailed training in that company's heat map, nobody else can figure it out, so it doesn't matter if you see it or not. And that's a problem. So here we are. How do we now start to talk about, if I want to represent at least 3 dimensions, what do I do? Okay, we know. We add the Z dimension. Now, people start to say beyond 3 dimensions. I certainly personally, I get a little fuzzy about that, but people will say, well, I can represent 6-dimensional space. Now, I wonder if that's a little bit of a stretch. I say that it's a clearer way to say that is I am representing 6 individual variables in 3-dimensional space. So how would I now, in this 3-dimensional space, represent 6 variables? Add some more, add an A, B, and a C vector in there? No. Here's what I would do. Here's what I am doing. You create shapes, 3-dimensional shapes, in that 3-dimensional space. So now I have X prime, Y prime, and Z prime. Are you with me? This makes sense? And so all of a sudden, this is not a devilishly complicated heat map. Anyone can figure this out because we're already wired up, genetically wired up, to recognize moving 3-dimensional shapes in 3D space. So this might be a single entity. If I'm a stock trader, this might be a company that I'm following. Well, what if I want to follow a whole bunch of companies? Right? What if I now start to add some, another thing that we all learned in MBA school is you got to be able to do quadrants, right? You're not a good MBA unless you can divide your market space into quadrants. So what if I start to divide my 3D space into quadrants and then put in some simple algorithms that will alert me when interesting things happen? Like in this case, what I'm seeing is a company where there is high gross profit and a low stock price. Well, obviously, I'd want to know about that. And what if I started to create an environment that was somewhat like the marriage between a jet fighter pilot and the avionics in the cockpit? I'm sure any fighter pilot would say you need both the human intuition and the human whatever it is, that je ne sais quoi that humans bring, along with, of course, you need all the avionics to do all the calculations and show you that data in a comprehensible form. So imagine, in effect, I get a radar lock-on for a target that I ought to know about, and then I have preloaded some standard responses to interesting data patterns. In this case, it would be a buy right away. Am I starting to now find a way to navigate through 3-dimensional space, big data in real time? Does that make sense?